All right, yesterday you may recall that I taught you about domain and range. I'm going to give you a picture here quick and see if you remember. If I had a graph that looked like that, what would its domain be? Yes, it's this way to this way, and how far will it go? Negative infinity to positive infinity. How about its range? Not zero, it goes lower than zero. Negative infinity to positive infinity. So its domain and range are unlimited. Yes, ma'am. Oh, not right now. Maybe in a bit. All right. I want to make sure you get another, fairly simple one here. Let's say it was a V shape that goes right up like that. What's its domain? And instead of saying negative infinity to positive infinity, what's the really fast way to say it? All reals. Okay, all reals, and then what's its range? Not 0 to negative infinity to 0. Okay, it's how low to how high. And how low is negative infinity, how high is 0. Okay, so its range was negative infinity to 0. And if you had a picture like this, a problem like this where you had x plus 3 and you did not have a picture, it's supposed to be a plus, it's not looking right, plus 3. And this one would have a problem in the denominator if x was ever negative 3. And so you'd say everything works except what? Negative 3. And would you need to draw a number line and do the negative 3 and test both regions? Not really, because on this kind, everything works except negative 3. So you can just automatically fill them in. But on this kind from yesterday, you had x minus 4. You had to say a whole range of things would work. So you had to have a number line, and you had to pick out what's the important point. It's where x minus 4 has to be greater than or equal to 0. X is greater than or equal to 4. 4 is the important number. And now you need to test on both sides. Couldn't you just trust and go to the right? No. I'm telling you, testing intervals is huge in this class. And that's a lot of people got this wrong in the last test. So it works at 4, and you'd want to test 5. It's really easy to test. You stick in 5, and you ask yourself, did this crash my function? Did it? No, it didn't crash it, so it works. And then you test over here and test something like 3. Would this crash my function? Yes, because I'd have a negative underneath the root. 3 minus 4 is negative 1 squared, and negative 1 is not possible. There's your final answer, except you'd normally would write it from 4 to infinity like that. Any questions? That's what you did before. Okay. Homework for today is just like that, except, in fact, it was so easy for today that I'm going to choose today's our day to double up. Do you remember how I slowed down a day and gave you an extra day to take that test? Well, you eventually got to pay the piper, and today is the day where we're going to double up. Now, I'm not going to assign both worksheets, all of them. I'm going to assign both worksheets, half of them. Do you get that? Means you still only have one worksheet effectively, one full set of problems. Okay, so I know it's more things to learn, but I need to teach you the other stuff because today was kind of a review day, so it's the perfect day to actually, instead of having a review day for stuff that's pretty easy, we'll do some right now together. I'm only assigning the evens, and I'm going to do some of them with you. Or actually, it's every other letter because it's A, B, C, D, E, F, G are the problems. So it's kind of harder to do evens when it's all letters. All right, 2, 3, 4, 5, 6. So we're going to do every other letter because there's no such thing as like even letters and odd letters. So I suppose we could do like letters that are not in the name David server. That would be an interesting way to do it. Or we could do like skip A, E, I, O, and U, and sometimes Y. Well, anyway, we're doing every other letter. So you can just cross off every other letter. So you can cross off B, and D, and F, and H, and J. Yep, that whole row. And of the ones that remain, let's not do A together because it's so easy. You can have a nice, easy, free one yourself there later. I'm going to do C with you right now. So problem C on the worksheet I just handed out, which is worksheet 1.2, worksheet 2. It's part C, 1C, is f of x equals 8x squared. First of all, is there any way to crash 8x squared? Does it have a square root to crash? No. Does it have a denominator to crash? No. So you can't crash that part. So you know what? From then on, you don't even have to worry about that part. Just ignore it. What you got to worry about is the other part of the function. plus that part you could crash. Square root of negative 2x plus 3. So my advice to you on this would just be to, seriously, just go like that. You can't crash that part, so don't worry about that part. What you're trying to find is things that will crash your function. And I'm going to try to find what could this have a problem. It's not that I'd have a 0. 0 is not a problem. It's if I ever get a negative underneath there, so I got to set this negative 2x plus 3 greater than or equal to 0. Take whatever's under the root and do that. Go ahead and do that. Solve it. Make a number line for it. Test both sides of your important point. See if you can do this without my help. Yes, ma'am. It's always should be set greater than or equal to. Yep. So we're subtracting 3, and we got negative 2x greater than or equal to negative 3. All right. And then did anybody remember that when you divide by negative 2, you've got to switch the sign? When you divide by a negative, like I just did, I divided by a negative on both sides to solve this thing. I'll do it in a different color here just to make the point. Let's say I divide it by negative 2, divide by negative 2. When you divide or multiply by a negative, the sign has to switch. So it may change from a greater than sign to a less than sign. It doesn't even matter that much because I still want you to test the interval, and you'd keep yourself from messing up by testing the interval. Because see, we now get that the x is less than 3/2, which is 1.5. As long as you do what I said and test 3.5, you won't mess it up. We have to test both sides. If you just trust that it's this way, then you might mess it up. So don't. Never trust these. Test them. Okay, so if that's 1.5, I'm going to test 2, and I'm going to test my favorite thing, 0. Okay, I'm going to go put 2 in this thing and see if it messes it up. Negative 4 plus 3, that messes it up, doesn't it? I get a negative underneath the root, so that's not good, so I can't use those numbers. And I'm going to test my favorite thing, 0. If I put in a 0 here, cancels that. Square root of 3, that's not a problem. As long as it's not negative, I'm okay. So it did work this way, and it's just not smart to just assume. All right, so final answer would be from negative infinity to 3/2, where bracket on this one, curve on that one. Switch the sign. Yep. If you have to divide or multiply by a negative when you're solving, you got to switch your sign. All right. On number 6, what's the part that couldn't crash? Oh, wait. I'm sorry. Not that. I was looking at the wrong sheet. Forget number 6. Okay, let's flip it to the back side. Number 2A. Same deal on the back side. We're skipping every other letter. So we're doing A and we're skipping B, and we're doing C and we're skipping D. So 2A. How am I supposed to find the range of that? Well, I have to know what it looks like. I hope you remember how your functions kind of look. Because do you have to be super picky about how it looks? No. I mean, what if you don't remember exactly how to stretch your V shape? You at least need to know it's a V shape and it's been stretched. Do you think it really matters how wide that V is to tell domain and range? No, it really doesn't matter. Now that +1 does matter though. That matters if I move up or down because that's going to change my range, right? So I got to be careful where I move that. How wide the V is, kind of irrelevant. All right, so there we go. I moved it up 1 like I was supposed to. Now I can look at my picture and say, what's the range? Oh, what's the lowest it goes? Highest it goes? Easy. All right, so that's just a review of what we did yesterday. The one exception to the skipping every other problem thing is I want you to do all 3 review questions on that worksheet. I'm trying to make the point that the review problems are seriously more important than regular problems because of the way we do these cumulative tests. If you don't do the review problems, you will forget the stuff you did 3 weeks ago. If you do the review problems, you won't forget them. We'll keep reminding you. But if you choose to not do the reviews, you're going to not remember when we hit the cumulative test. And the cumulative test has the power to not only be a test, it also can be a redo of old tests. So it's very important you do your review. Okay, now on to the new stuff. What I really need to teach you so we can be all caught up with all the other classes today. I need to teach you section 1.2 worksheet 3, which is basically about increasing and decreasing and intervals where things are increasing, decreasing, or constant. Okay, do you agree in the United States we always read from left to right? So then if I say that, is it increasing or decreasing, you should be, without any other labels, you still should be able to say it's what? Increasing, okay? Because we read from left to right. So if you're looking at a graph, typical problems goes like this. You got to be able to identify where it's increasing and where it's decreasing. And the points where it changes is considered a point of inflection. It's not that big important of a word, but it's true. And it's changing from increasing to decreasing or decreasing to increasing at those spots. So those are kind of important, right? Those have names. This is called a local max. The low spots are called, take a wild guess, local mins. Okay, they're just like low spots. Minimums are where water would collect. Okay, here's a weird kind of exception to the rule thing. Do you get how there's no real spot where it ever changed exactly? There's no low spot in there, so that doesn't have any local minimum in there. If they put a big dot right here, it's because it changed from increasing at a decreasing rate to increasing at an increasing rate. All right, that's a nice point, but it is not a local minimum. Think of it this way: would water collect there? No, it would just run right off. Okay, so that's not a minimum. If water would collect there if it was a minimum. All right. So now those local mins and maxes are easy. The part that's a little harder is trying to say where is it increasing and decreasing. If this is the point right there, let's say it's 4, 3. That kind of looks about right to me. And this one's at like -2, 8. Then would you agree it is decreasing in this little zone between those 2 points? Do you get how that's decreasing? That's called a decreasing interval. And all I got to be able to say is, how do you describe it mathematically that it's decreasing in there? You are talking about the x's. So if I drop this thing down like this and down like that, it's from here to here that it is decreasing. So it's the x's. So it's from -2 to what? To 4, where it is decreasing. And now this can be either brackets or parentheses. It does not matter. Because you could have an argument with somebody pretty good argument on both sides as to whether at the point 4 it's actually still decreasing there, or did it stop decreasing at 4? You could have a good argument. So the point is, you can use either brackets or parentheses. I don't care. I use parentheses, but you can use brackets and I won't mark it wrong. Okay? So then, how would we describe this interval right there? Would you please write down what you think you should write for this kind of a dealy, Bob? How do you describe the black one that I just drew on? That's an increasing interval. What would you write? From what to what? So do you use the 3 or the 4? The 4. Now, I know a lot of people think 3 because you want to say, well, but it's going up. You only use the x's when you're doing intervals. Okay? We aren't going to have you do the y's for these. So your increasing or decreasing intervals are only the x's, so you don't need that number. It's just the 4. And then how far will it be increasing? Well, it's increasing until it hits what? Infinity. All right, here's another one that really often, I'm going to give you one more easy one and then I'll give you the challenge one. So let's go like that. What's this spot, and this spot called? Well, that's and that are the same thing, and they're called local what's? Maximums in this spot. Local min, all right. Let's say this is at the spot 2, 2. Let's say this is at -3, 8. And then let's say this is at 12, 13. And then let's say this is at the spot x is, let's say, 15, 0, right there. Does that point even matter? At the point 15, 0? No, because it keeps going through that, and it's not a low spot or a high spot, so first thing I'd want to do is just ignore that. Okay. All right, so tell me, list all the intervals where the function is increasing. And intervals just means something, something. Try it on your paper right now. the intervals where it's increasing. Well, this one's a pretty obvious one. It's increasing right in there. And so hopefully you remember that server side used the x's. So it's 2 to 12. And I said you could use either. I'm going to use parentheses. Raise your hand if you had 2 to 12 on your list. Good. Is there another one? Yes, there is. Yes. Because in this little zone right here, it's increasing too. As you read from left to right, it is going up, right? I know some people are like, but the arrow's going down. You read from left to right. So that's an increasing interval. So it is increasing from, well, where does it start increasing from? Well, it's forever this way until it hits there. This is the interval we're talking about. Not this way. That's a range. You're not doing range. This is the interval. It's increasing from negative infinity until it hits what? Only the x's, so it must be that. Negative infinity to negative 3. Raise your hand if you had that one right. Okay, good. All right. Next thing. Constant. There's such a thing as constant. Yes, but it's kind of rare in the real world. A lot of times, like the temperature. Temperature's rising or falling and rising and falling throughout the day. If you're really zoomed in, it's very rarely ever constant. But we can force it to be. So let's say the temperature does this and it stays like this for a long time, and then it starts going up. Then this little zone right there, what's that called? The plateau, good. It's also known as constant. That is constant. It's remaining the same. I was trying to make it completely flat. Okay, so like let's say that the temperature was 6 degrees. It stays at 6 degrees the whole time. And then all of a sudden it starts taking off again. Okay, so if we had one like this, we could say that it was increasing until it hit here, then it was constant, and then it started, from this point on, it started increasing again. Okay, so this was increasing, this was constant, and this was increasing. You get the concept of constant? Okay, and I think we should just get this worksheet out to you also, and we'll start doing a few of these. This is increasing, decreasing, and constant. Thankfully, 2 fairly easy days we can put together. In this worksheet, remind me, we got to do not all the problems. We're going to do every other again. All right, this one is numbered, you know, like normal. It's 1 through 17. So why don't we just do the odds, right? Odds at the top. Odds. All right, so here we go. Number 1. Got that picture. You need or have, oh, there it is, coming up. I'll take it, thank you. All right, number 1, the picture kind of looks like this. You don't have to draw the picture, of course, but I do. There we go, and it goes -1, 4, 2, 2, 5, 5. And then it says, state whether each labeled point identifies a local minimum, local maximum, or neither. I'd be fine with you abbreviating, and you'd call this L max. This would be a L max. This would be a L min. You just write it right on the graph. That's identifying them. Okay. Identify intervals on which the function is increasing and decreasing. So now I should write some intervals. I'd put an I next to ones that are increasing. It's increasing from, remember you can always put parentheses. Increasing from, remember it's x, it's this way. From negative infinity until it hits what? Remember, only the x, only the x numbers, -1. Where's another place it's increasing? It's also increasing in this little zone right here, right? So that's from 2 to 5. And that's it for increasing. Now I got to label my decreasing ones. So I go D. My decreasing ones are here to here. Remember, it's only the x numbers. So -1 to 2. It's also decreasing. I should probably label this one as increasing. It's also decreasing from 5 to infinity. Now, a lot of people say, no, sir, but that's going to -infinity. No, it's going to infinity because it's from here. It's a this way thing, remember? It's x things. We're talking about what interval. The interval is x's. And we're not talking about y goes to infinity. Yeah, but we're not talking about y's. We're talking about x's. From in this zone right here, which is from 5 to infinity, it is decreasing. I can see how that would be a really easy one to mess up. All right. So, all right, let's move on. You'd skip number 2, you go to number 3. What's one point that is neither? 3, 3 is the neither point. Okay. Let's move on to graph the function and identify the intervals where it's increasing, decreasing, or constant. All right. I would strongly recommend that you have a graphing calculator for this, even though on number 5 you wouldn't need one. On number 7, I bet you don't know how to graph that, do you? I don't know how to graph that, unless I did an XY chart and just like plug numbers in and try to figure it out. But number 7, I would want to use my graphing calculator for that. And let's say that your graphing calculator shows you a graph that looks like this. Do you know how to find the low spot in a graph with your graphing calculator? All right, let me show you how, because you're going to want to know that one. So number 7 is super easy because it's a V shape, and so we don't have, it's easy to tell where the curve is, so to speak, where the low spot is. But let's do it on number 7, because that's one you have to do. So I don't want to do it on one that you don't care about. I'll do number 7. So I'm going to put this in my calculator, so I'm going to write it way up here. Absolute value of x plus 2 plus absolute value of x minus 1 minus 2. Remember my rule about this. If you're going to graph it, don't try to solve it first and then graph it, because you might screw it up. Better to just type it in exactly the way it is and let the calculator do the work. All right, so I'm going to get everybody, if you haven't got a graphing calculator, please get one right now. I'll pause for a moment while kids come up and borrow them. So, all right, to get absolute value in there, I'm going to go second right above the 0 in the catalog, absolute value of x plus 2, and arrow over to get out of the absolute value, and then I say plus, and then another absolute value. I'm going into the catalog to see it. I went too fast. Freaked out my calculator. There we go. And then I have x minus 1. And then I get out of my absolute values with the arrow key, and then I say minus 2. Okay. Now if I graph it, I bet you didn't know that was going to happen. It's like a V shape with a big flat spot in it, which is also known as constant in that flat spot. Okay. So now, how do we find that spot where it changes? All right, well, there's a few different ways. I could look in the table. Do you see how between x is 0 and x is 1, that y is staying the same? And as soon as it hits 2, then it starts to move. Do you get what I mean by that? Let's arrow up in the chart a little further. You see my constant zone there where y stays at 1 the whole time? You can see that in the table. It's one option. Okay. And then, so basically, can you tell by just looking at the picture? If you actually look at the graph, can you tell where that is? I can just look and see that it's at 1, where x is 1, where it makes the change, right? Okay. So if my job here is to identify intervals where it's increasing, decreasing, or constant, then this first part right here, I would say, is decreasing from -infinity until it hits 2. -infinity to 2. That's one of my decreasing intervals. Then the next thing is it's constant from 2, -2, sorry, thank you, -2. It's increasing from, or constant from -2 to 1. So constant from -2 to 1. And then from 1 to infinity, it's increasing. All right, let's get one where there's a curve in it. Like, for instance, number 9. Everybody go to problem 9. We're going to do that one right now. And it says 3 minus, parentheses, x minus 1 squared. 3 minus, parentheses, x minus 1 squared. Okay, I'm going to put that in on my y equals. Clear this thing off. Clear the ink, then get in here and go to 3. Clear that first. 3 minus, parentheses, x minus 1, quantity squared. There. If I look at my picture, I hit graph. How do I see exactly where that high spot is? That moment where it changes over from increasing to decreasing. That is a special thing under second calculate. You know how we've done second calculate intersect? It's second calculate, right above table there. Which one do you think? Maximum. You got it. If it had been a low spot, it'd be second calculate minimum. All right, maximum. And now, this is important. You have to read the questions it gives you. Left bound question mark. You have to tell it. You have to get to the left side of it. And you're creating a little boundary on the left side of it. Okay, am I on the left side of the top? Yes, I am. So I'm going to hit enter. I'm on the left side of the top. Now what does it say? Right boundary. I'm going to go over to the right of the top. I am on the right of it now, not on the top, to the right of the top, and I hit enter. Do you see how it puts in this little thing? See that? It's bringing in two little things that are saying between here, and then you remember guess, you always want to get really close to where you think the answer is. I arrow to the very top and I say, okay, it looks like it's about 0.85, but I'm not sure, maybe 1, I will see. I hit enter, and it tells me the maximum is 1.000023. It's one of the weird things about a calculator. It has to read its own graph, and it can't round. So it's off a teeny tiny bit. Can you tell it means 1? 1.000023 pretty much means 1. It has to read its own graph. Yours might say a slightly different number, but isn't pretty much, wouldn't it round to 1? See, my calculator and your calculator even give different answers. That's a weird thing, isn't it? Just round it to 1. Don't worry, we're not going to burn you on this on the test. You want to just round your answer, and it'll just be a nice whole number. Or if it's a decimal, it'll be like 0.5. It won't be anything really weird. Yes, ma'am?
We go by the X number.
Remember, it's always the X's.
Oh, yeah.
Okay, so it's 1. So final answer, that one's top spot is at 1. So what does that mean? That means when I actually am answering the question for number 9, what is the maximum? It's at 1, 3. What is the interval? It actually doesn't even ask for that, though. It asks for the intervals, where it's increasing and decreasing. Well, it increases in there, and that interval is from -infinity until it hits 1. So the increasing interval would be from -infinity to 1. The decreasing interval would be starting at 1, of course, and not -infinity. Remember, it's in intervals they're this way. The y is going to -infinity. We're talking about x's. So it's from 1 to infinity. It is decreasing from 1 to infinity. Okay. I know it was a lot for one day, but it was 2 days worth of stuff. So normal days shouldn't be this crammed, but it was today. Although when we get to trig stuff that you learn later, that's the real hard part of pre-calc, there'll be days that are longer than this. All right. So your assignment is to do the odds on that worksheet. On the other worksheet, you did every other one, and you have a bunch of work time now. Feel free to come up and ask me questions. I went over a lot of stuff. There is a little quiz coming soon on those top 20 things that you need to know for basic algebra. You know, that little sheet I gave you, top 20. That quiz is coming up soon, like in the next couple days. Okay, so make sure you are on top of that. Do you have to get 20 out of 20? No, but you should be able to. They're eventually going to get graded. I'm not going to say when for sure. I'll decide. If the vast majority of the class starts getting good grades, then I'm going to start putting them in a grade book. All right. And that's all I got for the recording for today.